All right, today we're going to work on some triangle congruence theorems. So you're going to see me use the triangle symbol congruence, and then I like to abbreviate theorem to THM, just in case you see that somewhere so that you know what it means. So there are 4 main triangle congruency theorems. We're going to look at a 5th one I'm just going to mention because it's going to show up on your Delta Math assignment, but it's not typically tested. So we're going to focus on 4 of them. So I'm just going to go ahead and give you the first one, and it is abbreviated as SSS, which stands for side, side, side. So our first theorem states that if 3 sides of one triangle are congruent to the corresponding sides of another triangle, then the triangles are congruent. So I'm going to give you a little example here of what that is going to look like. So given triangle ABC and triangle X, Y, and Z, if they are marked like such, where all of the sides are marked, you don't have any angles marked, but you have all 3 pairs of sides, then we can say that side AC is congruent to side YX. And you can see that A is between the 1 and the 2, and Y is between the 1 and the 2, so A matches to Y. And then if you have AB congruent to YZ and BC is congruent to ZX, then we know, I'm going to write ABC in order, and then we're going to match up the other one. So A to B to C gives me Y to Z to X. So triangle ABC is congruent to triangle YZX by side, side, side. Because we know that all 3 sides are congruent to all 3 sides of the second triangle, we know the triangles are congruent. So triangle congruence theorems are ways to prove that 2 triangles are congruent. Okay, so let's look at our next theorem. The second theorem is SAS, which is going to stand for side, angle, side. And that theorem states that if 2 sides and the included angle of one triangle are congruent to the corresponding sides and their included angle of the second triangle, then the triangles are congruent. So here's what that looks like. So So we have our two triangles. We will mark side AB and side BC. And the included angle is going to be the angle that connects these two sides. So B is in the middle of the two of them. And then over here, it looks like that. So we have two sides with an angle between them marked. So when we do that, we need a side, an angle, and a side. So our first side is going to be side length AB, congruent to side length DE. And then our angle, we have angle B, congruent to angle E. And then lastly, we have side length BC, congruent to EF. So because we have them and they match up in the correct order, we can say that we know triangle ABC is congruent to triangle DEF by side, angle, side. Okay, let me move this down and we'll do our next one. So we're on to our third triangle congruence theorem, and that's going to be ASA, which is going to stand for angle, side, angle. So this one states, if two angles and the included side of one triangle are congruent to the corresponding angles and the included side of a second triangle, then the triangles are congruent. So where the last one we were looking for the angle between the sides, now we're doing the opposite. We're looking for the side between the angles. So here's our diagram. We have triangle JKL, and triangle MNP. And then here we know we want angle, side, angle, so I'll write that in. And then let me mark this up for you. So we have angle J and angle L, and the included side is the side that connects those two angles. And then we have angle M, angle P, and the side that connects them. So our first pair of angles, we can have angle J is congruent to angle M. The side that connects them, we'll do side JL congruent to side MP. And then we have angle L congruent to angle P. So we can say that triangle I'm writing this wrong, JKL is congruent to triangle MNP by angle, side, angle. So two angles with the side that connects them makes angle, side, angle. And you can remember because it's in that order where the S is between the two A's. When I was in high school, that's how I liked to remember it. Okay, so the last official one that we're going to do we have AAS, so angle, angle, side. So angle, angle, side states, if two angles and a non-included side of one triangle are congruent to the corresponding angles and the non-included side of a second triangle, then the triangles are congruent. Okay, so here's what this looks like. Last diagram here. Okay, so we have PRS and then TUV, and now we want angle, angle, side. So we don't want the side to be between our two angles. We want the side to be kind of at the end. So when we read them in order, not included means that it's not going to be between the two angles. So if I've marked P and S, then my side needs to be one of these two that's connected to my empty angle. So I'm going to label this one here. And then in my other diagram, TU and then, or TV and then this side. Now it's important that you notice that the side has to touch the same matching angle. So in one of these diagrams, if I had labeled the side that only touches the single marked angle, then that wouldn't work because they wouldn't be set up in the same order. But for this, we're starting with our angle that's across from the marked side. So my marked side is here, so we're going to start with the angle that's across from it. So angle P is congruent to angle T. Then we have the angle touching the side. So angle S is congruent to angle V. Now we have our side. We'll do RS congruent to UV. And so we can say that triangle PRS is congruent to triangle TUV by angle, angle, side. Okay, so real quick, just the last thing that I want to mention is this fifth theorem. It's not ever included on the test that I've seen, the state test that you'll take at the end of the year, but it is going to show up on the Delta Math, so I would like to show it to you. It's called hypotenuse leg, or HL. Now, hypotenuse leg is very specific. It is for a right triangle only. So in a right triangle only, if you have the hypotenuse and one leg, then you can prove that the triangles are congruent. So if I have these two and I have a hypotenuse and a leg, hypotenuse and a leg. And the reason that this works is that you could use the Pythagorean theorem to prove that the third sides are congruent because they have to work in a right triangle. The Pythagorean theorem is always true. But they like to label this as hypotenuse leg. I'll tell you that on the state test, if a question like this is going to show up, it's going to be related to side, 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 and it's going to have the Pythagorean theorem in it. But if you see this, the reason I mention that is because there is you're going to see a theorem listed on Delta Math called SSA, which is side, side angle. That is not a congruency. So that is not congruent. Side, side angle cannot prove that two triangles are congruent. And the way that you can remember that is if you turn these letters around and you write them in the other order, that is not a word that we use in school. So that's an easy way to remember. But if you look at these diagrams, you have a side, and then an angle, and your 90-degree angle is only touching one of those sides. So this is the one instance where a side-side angle is ignored when we're dealing with a right triangle, and that's because hypotenuse leg exists and the Pythagorean theorem can prove by side, side, side. If you have any questions about that, you can always send me an email or attend my office hours to get clarification on this, and we can look at the delta math. But just know that hypotenuse leg is for a right triangle only, and it's where you have your right angle marked and then a hypotenuse and one of the legs. And that's it.